So this will probably be the last thing we do for our mid-chapter. So this will be day 7, and we'll wrap it up. We're going to do some fractions and factoring, putting those two things together. So it's called Simplifying Rational Expressions, and then once we're done with this, then we go back to regular chapter 6. So what we're going to do today is how do I simplify rational expressions, but we're going to do it by factoring. So let's first talk about rational expressions here. So what is a rational expression? I know it sounds fancy, but it's really not that big of a deal. It sounds difficult. It's very, very simple. So it's simply a fraction. That's where the rational comes from. In which the numerator, so that's the top part, and or the denominator are polynomials. So what are polynomials? That's the thing that we've been doing this entire time, right? When we did, GCF of, like, say, 3x plus 4, or we saw 2x squared plus 7x minus 7, whatever. These are all polynomials. They have multiple terms, so you could have any number of terms. So if you look at the examples down here, 4n squared plus 4n plus 1, the top is a polynomial of the numerator. The denominator is also a polynomial. You could also have something like this that we've dealt before. I think it was like the very first day we started working with this kind of stuff before we got into factoring, where we simplified these things. Also polynomials, but these ones just have one term. The ones over here, we have a 2 term on the bottom, which would be a binomial, and the top would be 3 terms, which is a trinomial. So that's what we're talking about. A rational expression is we have polynomials on the top and bottom of a fraction. That's it. So in order to simplify a rational expression, we're going to divide out a GCF of the numerator and the denominator. Now, this might sound tough as well, but we've already done this. This is like a review, essentially. We're going to start with these simpler problems like this first, which ones, again, we've already done. We're going to add a little bit to it a little bit later, and then we'll move on to these kind of problems. This will require us to do some factoring. Our example 1. So let's start with the easier types. Simplify each rational expression, and don't forget that when we do the exponents, they should always be positive. And let's go ahead and do this remember thing here, so that way we can use it for up here. So remember, when simplifying powers that are being divided, it's like when we simplify this m and m squared, or these x's, or these y's, what you can do is you can subtract the exponents as long as they have the same base. So don't forget that. We've used that many times before. All right, so let's simplify this. We have 7m over 21m squared. So let's do the numbers first. So if you look at 7 and 21 and think about how to reduce that, now remember, you can put that into the calculator and then change it to a fraction because it'll give you a decimal. Or you can just think, 7 goes into 7 and 7 goes into 21. So you can divide these both by 7, right? Divide by 7. Divide by 7. So that would be another way to reduce it. It's just reducing a fraction. Nothing special there. Divide that by 7, you get 1. The bottom, you would get 3. And then let's go ahead and finish this off. We have m to the first and 2 on the bottom. So if you remember, we do 1 minus 2, which is negative 1. And if you get a negative exponent, that means you have to put it on the bottom. So we can put it at the bottom and make it positive. Just a little bit of a review. Nothing new so far. All right, let's go to part B. There's a 3 here, but there's no other numbers by themselves, so that 3 is going to stay there. Let's do our subtraction with our x's. We have 3 minus 2, so there's 1 left on top. Do the y's. We have 1 minus 4, right? That would be a negative 3. So we can put that on the bottom as a positive 3. And maybe I'll just rewrite this. So we have 3x to the first over y to the third. Again, nothing new so far. We've done these before, just kind of refreshing on how to do it. So this would be if you had, just one term on the bottom, one term on the top. everything that we have between these terms, if you look, is all multiplication. 3 times x to the third times y. The bottom, x squared times y to the fourth. Same thing over here. It gets a little bit harder if we start throwing addition and subtraction between these terms and making them multiple terms. Right now, it's pretty easy, though. Okay, so let's talk about the thing we're going to add to this. It's called something, the thing is called a restriction. Rational expressions have restrictions on what the variables can be. So when you deal with a fraction, it's very important to remember that you can never divide by 0. So what does that mean? That means the denominator of a rational expression cannot be equal to 0. Let's see exactly what this means. It's called a restriction of what you cannot have. So let's go through this example here. It's actually kind of done for you. So if you have r divided by 6 plus r, right? The restriction is the question of whether, like, what could this be? So that way when you add a number to 6, it becomes 0. Because that's something we don't want, right? So the restriction here is saying that r cannot be equal to negative 6, right? Because if it were equal to negative 6, that's what it shows over here, you would have negative 6 on top, negative 6 on the bottom. If you added these two together, you get 0, and you're not allowed to divide by 0 because that's undefined. So we call the restriction is r cannot be equal to negative 6. So we're just going to practice doing that, thinking what makes the denominator 0. So example 2, determine the restrictions on the values of the variables. So I don't really care what's in the numerator. All we care about is the denominator, right? We look at the bottom and say, okay, 5 times x, right? We don't care about y. Y can be anything. You can have 0 on top, but we don't want this to be 0. So what would be the restriction? So I would say x cannot be equal to what number? Now for this one, you can't say negative 5, right? Because if you were to plug in negative 5 for x, that actually is okay. We have multiplication here. That would give you negative 25. That's okay. We don't want it to be 0. So what would you put there to make it 0? Right? It's something that we don't want to have there. What would that be? Oh boy. If you think about it, 5 times a number to make it 0, that number would have to be 0 as well. So the only way to multiply two numbers together and get 0 is if one of them is going to be 0. So that would be a restriction. X cannot be equal to 0. Anything else you want to plug in there is fine. Now going over to part B, this looks very similar to the one we had up above in the box. 3k divided by k minus 1. If we look at the bottom here, because that's all we care about, what would you plug in here to make it 0? That would be our restriction. We'd say k is not equal to what? So what would you plug in here? Would we plug in 0 this time? No. 0 minus 1 is negative 1. That's okay. But how would we make it 0 is only if k would be positive 1, right? Because that would mean you would do 1 minus 1. That would give you 0, and we can't have that, so it's a restriction. Okay, so there's a huddle for you to do, just dealing with restrictions, right? Looking at these. This one has multiple variables, so you have to do 2 restrictions, a p and a t. You have to do p cannot be equal to and t cannot be equal to. Figure out what those are. So you have 4 total. And then we're going to move on to more than one term on top and bottom. And we will also still have restrictions. Okay, so first what we're going to do here, which looks a little different here. Now we have plus and minuses in here. We're going to indicate all restrictions on values of the variables, and then we'll simplify the rational expression. Okay, so let's do the restriction. I'm going to put it over here somewhere. So, can you see my cursor here? Okay, I'm going to put it over here. So what can x not be equal to? Think about what goes from the bottom here. It's something minus 3. So what would make it 0 is if we put in the number 3, right? Because that would be 3 minus 3. That's 0. Okay, so now that we have that taken care of, x cannot be equal to 3. How do we simplify this? One thing you cannot do is you cannot look at x squared and x and start crossing stuff out. You can't do this either. Does not work that way. The only way you can cross stuff out, like we did in previous problems, is if you have multiplication between everything. So if I go back here, the only reason we can subtract exponents here is because you have multiplication between everything here. You throw a plus sign in here, you can't do that. It does not work that way. Let me give you an example with just numbers, right? If I said 3 plus 9 divided by 3, right? The way you would solve this is you would add 3 plus 9 and then divide by 3. However, if you did it the wrong way and you said, oh, the 3's here will cancel, I can cross them out. So that means I just get the answer of 9. But that's not the answer. 3 plus 9 over 3 is actually 12 over 3, not 9. 12 divided by 3 is 4. So it doesn't work. Now, change this to multiplication instead. What if I said it's 3 times 9 over 3 instead of 3 plus 9? So can you cancel out now? Let's see. If I were to cancel those two, I would get the same answer of 9 like I tried before. But if I actually multiplied them together and then divided, 3 times 9 is 27, and then divided by 3, that does give you 9. So it's very important that you know you cannot cross things off when you have addition and subtraction between two things. What we're looking for is two things being multiplied together, and then you can cross stuff off. So that does not work with these problems. So the question is, well, how do we make, things be multiplied together only to cross stuff off? And the only way to do that is to fill in this blank over here. In order to cross anything out first, you have to factor if possible. One implication of where you need to factor. So now you have to know all the forms of factoring to do this. How do we factor something like this? The top one can be factored by using shortcut. A, B, C. We're multiplying to 3 and adding to negative 4. I'll put that off to the side. So a lot of this stuff over here is going to be like side work, which you might have to do. So multiplying to 3, adding to negative 4. Oh, there we go. So how do you get that? The only way to multiply to 3 is to use 3 and 1. However, how are you going to get negative 4? Both have to be negative. So if you remember from shortcut, this is where it's important to know how to do shortcut and not always do the long way. We have to do shortcut. It just takes so much time to do it the long way, so I'm going to do shortcut. So we're going to do x minus 3, x minus 1. The bottom you cannot do factoring. There's nothing here. You may think difference of squares, but 3 is not a perfect square, and you also only have x down here. So I'm just going to copy this part down. However, look at what we have. We have a set on the bottom that's x minus 3, and we have a set on top that's x minus 3. So now we are allowed to cross them out, but the only reason we're allowed to is because we have a set of something being multiplied by another set of something. This is very crucial. Now we have two things being multiplied together. It's very much like the example I gave before. We have 3 times 9 over 3. This set matches the bottom set to cross out. So what we're going to do is cross them out. And then what do we have left? We have x minus 1 over nothing, right? 1. And so you really could just write x minus 1, no parentheses, no fraction at all. That's your answer. Part of the answer you also need is the fact that I'm going to put a little comma here. X cannot be equal to 3. That is still part of your answer, and you need both things to answer it. So our answer, so it's kind of weird how we started with something like this, but this simplified is actually that. It's just x minus 1, but x cannot be equal to 3. All right, let's try another one. But you have to know your types of factoring. It's still going to come back to you and haunt you. All right, we're going to simplify and indicate all restrictions on the variables. So in this particular case, it's not easy to particularly see what would be the restriction on the bottom, right? You're putting in a variable, like putting a number in for both of these to make it 0. That's tough. So what we're going to do first is we're going to try to factor this, and then we can figure out what would be 0. So I'm going to factor the top and the bottom, actually. Let's do the bottom first. So if you notice, this is shortcut. No number out front's 1. So this is where you do your 2 sets of parentheses. We're going to go off to the side, and we're going to say we're trying to multiply to get 9, add to get -6. All right, you might be able to figure that out in your head, hopefully. That would be 3 times 3, except for the fact that we have to have -6. So they're both negative. There we go, something like that. Okay, then we're going to fill in the blanks here. X minus 3, x minus 3. So now we can look at this and say what are the restrictions. So I'll go off to the side here. X cannot be equal to what? Now it's much easier, right? What could you plug in there to make it 0? That would probably be 3, because 3 minus 3 is 0. Same thing happens over here, right? If you plug in 3 on this side, 3 minus 3 is 0. So that makes the whole entire thing 0. So if we had 3, that would be bad. Not so obvious to look at this and know it's 3. This way it looks a little easier. Or how about the top part? We have 7b minus 21. This is not shortcut. We have 2 terms, but it's not difference of squares. It looks like we might just have GCF. So what comes out of 7 and 21? We can take out a 7. So now we have 7 times b minus, divided by 7 here, 3. Oh, whoops. I'm sorry. I forgot to use b's. That might mess things up. Yeah, let's change that to a b. B. Here we go. Now it's a little easier to see. Should also write b here. Careful with that. That wouldn't match up too well. Now if you see I have 7 times b minus 3. On the bottom you have a b minus 3 times another b minus 3. So what happens? You would cross this one off with one of these. Not both of them, just one for one. And we would still have 7 on top, and the bottom would be b minus 3. If all you have is one set of parentheses, you don't need to write the parentheses there. If you want to put them there, that's fine. You don't have to, though. So our final answer would be this, with the restriction that b is not allowed to be 3. That's it. I think I have one more left, and then we're done. So again, this would be a amazing case of saying what not to do is that students will see 4n squared on top and 1 on the bottom and be like, okay, there you go. So it's 4n plus 1 over -1. No. You can't do that at all, right? I just showed you with the 6 and 9s that you can't do that. So in any case, we should probably remember to factor first. Again, this is another one on the bottom where it might be difficult to see what makes it 0. We need to have a restriction at some point, what n cannot be. But I'm going to do some factoring first. Let's first do the denominator as a factor. So let's put a little equal sign from up there. And we'll do the denominator first. So what do we have here? Clearly no GCF. But these are both perfect squares. So let's do difference of squares. How do you get 4n squared? That would be 2n and 2n. How do you get 1 or -1? We have to have 1 and 1, 1 plus, 1 minus. There we go. Still pretty difficult to see what would be the restriction here. So if you can't figure that out, you may have to go off to the side and do some work. So what I'm going to do is I'm going to take this denominator, each set by itself. I'm going to do 2n plus 1. I'm going to set it equal to 0 and then just solve this for n. I'm going to do it twice. I got to do 2n minus 1 equals 0. If I solve this for n, that will tell you the value that you cannot put in there because that would make it 0. So it's pretty simple to do. We're going to minus 1 on both sides. So 2n equals -1, then divide by 2. So what we cannot have is negative, whoops, that's bad. We can't have -1/2. That would be bad. So I'm going to put that in there, -1/2. Do the same thing over here. you would add 1 to both sides. 2n equals 1. 0 plus 1 is 1. Divide by 2. These should be nice and short for the most part, just 2-step problems. And you also cannot have 1/2 because that makes it 0. That's bad. So you put comma 1/2, or you could alternatively write plus minus. I think I'll do that this time. So there's the restrictions. We actually have 2 this time. Now we have to factor the numerator. This might take us a little bit because I don't know if you noticed this, but there is no GCF between 4, 4, and 1. That means we got to do the AC method the long way. Uh-oh. Oh, yeah. Here we go. Not sure what I'm doing here. Here we go. So we're going to have to do the ABC on top. So again, we need more space to write our answer out here. I'm going to go ahead and go down here. We need to do A times C, which equals 4. All right, 4 times 1. And we're going to add to get 4. Well, that's not going to be so bad, right? How do you multiply to 4 and add to 4? You got to use the same numbers in this case. 2 and 2. That works. All right, we're doing the long version, so we have to do this by splitting it up. We have 4n squared plus 2n plus 2n plus 1. And we got to do some grouping. I'm going to go through this kind of fast because you should know how to do grouping by now, so we can finish this video. I can take out a 2n from both of those. I'll be left with 2n plus 1. Here, we already have 2n plus 1, so I'm going to take out a plus 1. 2n plus 1. We actually have the same thing twice here. 2n plus 1, 2n plus 1, so I'm going to write that out once. That goes away. And then what do we have left? Another 2n plus 1. We've seen this before where we get the same thing twice. It's not a big deal. So we have a 2n plus 1. Now we can finally answer the top part. And another 2n plus 1. I don't like how thick this is, really. Maybe a little better. So what can we do here? We have 2 things that match up here, the 2n plus 1s. However, this one does not match. The 2n minus 1, you can't cross out both of them, unfortunately. So we can cross out the top one with the bottom one. That's 2n plus 1. But they don't cross out. They have to be exactly the same. So we're going to leave this as 2n plus 1 on top, nothing else. The bottom is 2n minus 1. And with our restriction that I'll add over here, n cannot be equal to positive or negative 1/2. So this is obviously like one of the hardest types that you'll see. It takes a long time to do it, especially if you're not good at factoring. You have to be good at it. This also had the additional kind of difficulty of figuring out what makes it 0 as a restriction that you cannot have. So add that into the whole mix of doing the long method on top and difference of squares on the bottom across. So it can be a long process. Again, we practice factoring so much. I hope that you're pretty good at it by now and that it doesn't take as long. Even with the long method, it shouldn't take too bad. It shouldn't be too bad. So, but it is kind of crazy to think, this answer here is the exact same answer as this. It's just simplified, right? We're doing something called putting it into lowest terms. And I think that should be everything for you to do the huddle and the mastery. These problems take a little bit, take some time. I don't think there's too many where you have to do a lot of work as far as the long method. Most of them are shortcut method. That should be everything then for day 7, and we're almost getting ready to wrap up the factoring, and we'll go back to chapter 6 soon.